Hello everyone. Today we design and simulate single phase transformer by using ansys Maxwell. So start the step. First open the ansys electronics, double click on ansys electronics and wait. This is our ansys electronic desktop. So after the open desktop, what is the next step? Next step is to insert a design. Here design is Maxwell 2D. This is our Maxwell's. Click and explore Maxwell and select design is Maxwell 2D. This is our modular window. This is X plane, Y plane. So what is the next step? Next step is set a solution type. For set a solution type, go to Maxwell 2D, click on solution type. Here geometrical mode is Cartesian XY and our solver is transient, and click on OK. Here we select the solver. Here solver is transient and geometrical mode is XY. After that, what is the next step? Next step is this set model unit. For set model unit, go to modular and click on units and select unit in mm and make it OK. Here unit in mm. After that, after the completion of this step, next step is create a model. Here we create a model with the help of rectangles. First start with core. Here we draw a core with the help of rectangle. Select rectangle from draw and select rectangle. First put the coordinate of x, y, z. Here we set the coordinate of first rectangle x0, y0, z0. Make it OK. Here dx is 200 and dy is 40, dz is 0. Make it OK. This is our first rectangle. Scroll the mouse and minimize the size. Here we scale it 300 mm up to. After that, completion of first rectangle, we create another rectangle. For create another rectangle, again go to draw and choose rectangle. Put the coordinates of second rectangle. X is 160 and y 0, z is 0. Make it OK. Here dx is 40 and dy is minus 160 and dz is 0 because our plane is xy, so d and dz is always 0. After completion of here we create a limbs of transformer. After that we create a base of transformer. Again go to draw and choose rectangle. Put the dimension of rectangle is, first we assign coordinates. Coordinate is x is 160, x is 160, y is minus 160, y is minus 160 and z is 0. Make it OK. After that, put the value of dx is minus 160 and dy is 40, dy is 40 and dz is 0. Click on OK. This is third rectangle. After the completion of third rectangle, we draw the next limb of transformer with the help of rectangle. Again go to draw and choose rectangle. Select the coordinate of rectangle is x0, y0, z is 0. Click on OK. dx is 40, dy is minus 120, and dz is 0. Make it OK. This is our transformer core. Here we create 4 rectangles. This is not a unit core. Here we create a unit core with the help of modular menu. So first select all rectangle from history tree one by one. Here we select all rectangles, rectangle 1, 2, 3 and 4, and go to modular, and here we choose and explore boolean and click on unit. This is our unit core. After the completion of this step, what is the next step? Go to property and double click, go to history tree and double click on rectangle 1, change the name is core, and here we made core with the help of steel 1008. So next step is assign material is steel. Here search by name, type the name steel underscore 1008, double click on it and assign the color of core. Okay, it's fine. This is our core. After the completion of core, we create a coil. Okay, for creation of coil, again we go to draw and choose rectangle. First put the first choose the coordinates. Here coordinate is x is 210, x is 210, and y is minus 10, and z 0. Make it OK. dx is 10 and dy is minus 100, and dz is 0. After the completion of first side coil, we create another coil. This is your positive polarity. Here we create a negative polarity rectangle. Again go to draw and choose rectangle. Put the coordinate of rectangle is x is 140, y is minus 10, and z is 0. Make it OK and put the value of dx is again same, dx is 10 and dy is minus 100, and dz is 0. Make it OK. This is your lower voltage winding. After the completion of lower voltage winding, we create another winding called higher voltage winding. Here we again go to draw and choose rectangle. Put the dimensions of first choose the coordinate is x50, y is minus 10, and z0. Press enter key and put the dimensions of rectangle is dx is 20 and dy is minus 90, dy is minus 90, and dz is 0. Make it OK. Again go to draw and choose rectangle. Put the dimensions of rectangle is x is minus here first we select the coordinate x is minus 30, and y is -10, and z is 0. Click on enter, and dx is 20. Put the same value of dx and dy in previous case of a rectangle, and dy is also 90, and click on OK. This is your higher voltage finding. After the completion of this step, select all rectangle from history tree. Here we select all rectangle from history tree and right click on any rectangle and click on assign material. Here search copper. Here we search copper, select copper from library and click on OK. After the completion of this step, select a rectangle one by one. Start with rectangle 5, double click on rectangle 5 and change the name is coil underscore primary underscore positive, and assign color is brown, make it OK. Again double click on rectangle 6 and change the name is coil underscore primary underscore negative, assign color is brown, make it OK. Again double click on rectangle 7, change the name is coil underscore secondary underscore positive. Here we use a short name, choose a brown color, make it OK. Again double click on rectangle 8 and double click on it, open the property window and change the name is coil underscore secondary underscore negative, and assign color, put this brown, make it OK. Here model part is completed. After the completion of model part, we assign the model depth. For model depth setting, go to Maxwell 2D and search design setting. This is design setting, click on design setting and go to the model setting tab and write down value of model depth is 51 mm. Model depth is 51 mm and click on OK. Here design setting part is completed here. After the next step is, after the completion of design setting and assign the model depth, we go for excitations. First start with first coil primary positive, OK. Right click on, select coil primary positive, right click on it and select assign excitations, explore it and select coil. Here don't change the name, put the conductor value. Conductor is for primary winding, we 50 conductors and polarity is positive, make it okay. After the completion of assigned conductor for primary coil, select coil primary negative from history tree, right click on it and click on explore assign excitation and choose coil. Put the number of conductor is again 50, but here we change the polarity is negative, make it okay. Here complete. Here we done for lower voltage winding. We apply conductors for secondary winding. Choose the coil secondary positive from history tree, right click on it and explore excitations and click on coil. Don't change the name. Number of conductor is 250. Here put the conductor is 251. Here we put the conductor value is 251 and polarity is positive, make it okay. Don't change the polarity. And after the completion of coil secondary positive, select the coil secondary negative from history tree, right click on it and explore assign excitation, choose coil. Here number of conductor is again 251 and reference, here we change the reference direction is negative and make it okay. For this coil we assign polarity is positive, and for this we assign polarity is negative. Again from the right side of coil is positive and left side is negative. Okay, after the completion of assigning the coil conductor, next step is create winding. For creation of winding, go to project manager. This is your project manager. Go to project manager and explore project manager and right click on excitation. This is your excitations. Right click on excitations and click on add winding. Okay, change the name is secondary winding, SCC secondary winding. Okay, I write short name secondary winding and here change the parameters. Type is voltage and conductor is stranded. Initial current is 0 ampere and resistance is 2 ohm and inductance value is 250 millihenry and voltage is 311 multiply sine sin sine, use the small bracket, write down 2 multiply pi, again put the symbol of multiplication, write down 50, again put the value of multiplication and write down time and close the bracket and write down unit is volt unit is volt, and make it OK. Here we create a secondary winding. After the completion of secondary winding, again go to project manager and right click on excitation and click on add winding. Here change the name is primary underscore winding, and change the parameter is voltage, and conductor is 200, initial current is 0 and 0 ampere, and resistance is 4 ohm. And put the value of inductance is 300 millihenry, and don't apply voltage in our high voltage side, and make it OK. Here we create a primary and secondary winding. After the completion of this step, we add coil in the windings. So primary coil add in primary winding and secondary coil add into secondary winding. Start with first, this is our primary winding. Right click on primary coil, this is our primary coil, and click on add to winding. Here winding is primary, make it OK. This is also primary coil, right click on it and click on add to winding. This is primary, select primary winding, make it OK. These coils are secondary coils, so winding is secondary winding. Add coil in secondary winding, right click on this coil and select add to winding. Winding is the secondary. Again do the same step, right click on coil underscore secondary underscore negative, click on add to winding. Winding is secondary, make it OK, and click on binding. Here we add to both coils in secondary, we add the coils. This step is done. After completion of this step, next step is create a boundary. For boundary, we go to draw and click on regions. Here choose pad or direction. Similarly, put the percentage offset value is 50%, make it OK. This is our boundary. Go to Maxwell 2D. Here we assign a boundary. Go to Maxwell 2D and search boundaries, assign potential. Select planes and go to Maxwell 2D, search boundaries, assign vector potential. First select the boundaries. Here we select the edges of outer side. Go to edit and change the selection mode. Mode is edges. Select all edges and again go to Maxwell 2D, click on boundaries, assign vector potential and make it OK. Here we apply a boundaries, the vector potential 1. After the completion of this step, go to Maxwell 2D and apply validation check. Here analysis setup is not done here. Close this window, and the next step is go for solution setup. Explore Maxwell 2D and click on analysis setup and add solution setup. Here stop time, put the stop time is 0.5 second, 0.5 second, and time step is 0.002 second, and go to save field. Here sweep setup, here type is a linear step and start with 0 second, and stop time again put 0.5 second, 0.5 second, and step size is again put 0.002 second, and click on add to list, and after that click on OK. Again check, apply validation check. Here some warnings in our analysis setup and boundaries, but it's okay. Go to Maxwell 2D and put the model in analyze mode. Save the project. And exp7, save, and double click on show progresses. Here simulation is going on. Wait for some time. Okay, double click on meshes. Here normal completion done in local machine. Okay, here we start with first we plot a flux plot in our core. Go to edit and click on select all, and go to view, click on set solution context. Here provide time, anytime, click on OK, and go to Maxwell 2D fields, click on A, flux lines. Here select core and click on OK. Okay, this is flux lines plot. After the flux, here we generate a flux lines. Okay, after that we plot magnetic flux density. So remove this flux lines plot, or remove this flux lines plot. Go to project manager. This is our project manager, and explore field overlays, and right click on A and click on delete and confirm as, and again repeat the same, again do the same steps. Go to edit and click on select all, and go to Maxwell 2D fields, again go to fields. B is a magnetic flux density. Click on B magnitude. Here select core and click on done. This is our magnetic flux density plot in our core. After the completion of this step, we plot a rectangular plot. So for the creation of rectangular plot, go to project manager and right click on results and click on transient create a transient report, explore it, and select rectangular plot. Here select in category, select a winding, and select first we increase the size of this, and select the induced voltage in secondary. Click on generate a new report. This voltage is generated induced in secondary, and check for induced voltage in primary. Click on new report. This is your voltage induced in primary. Click on add to traces. This is your plot. Okay, red one for induced voltage in primary, and this is your violet color for secondary winding. Close this tab, and we also here we put some animation. Okay, go to view and click on animate, or select here magnitude P1, make it okay. Wait for some time. This is our animation with when the time is increasing and flux density is increasing, decreasing with respect to time. Here we clearly visible in this. Okay, so this experiment is completed here.